Jai Hind. I am Shivpratap Singh, Assistant Professor in CSE Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today, our topic of discussion is Hadoop Distributed File System. This topic covered under subject Big Data BCS 061. Let's start our discussion with HDFS. What is HDFS and why there is a need of HDFS? As we all aware about that in the today era, the data is very large and data is heterogeneous in nature. It can be structured data, it can be unstructured data, and it can be semi-structured data. And to store this kind of heterogeneous data in a single storage, the traditional DBMS systems like a traditional relational database system in which data is stored in the form of rows and columns is not efficiently manage this kind of data. So to manage this kind of heterogeneous data, we need a different kind of file system. For this kind of support, we have HDFS, Hadoop Distributed File System, to store and efficiently manage such kind of heterogeneous data in more than one machine, and the hardware is commodity hardware. So the design of HDFS is a file system designed to store very large file with streaming data access patterns running on clusters of commodity hardware. So what is very large file? The file that is having very large size like 128 MB, and we can manage this up to greater than 128 MB to 56 MB. So the file that stores in the Hadoop HDFS file system at least having size of 128 MB, because we have to handle large amount of data with the help of HDFS. So the block of a file, or we can say we have to divide a file into 128 MB of chunks. Then we have commodity hardware in HDFS. This is the main component of HDFS. We don't need to manage high capacity, high cost systems. The existing systems that can be less efficient, we can use that systems. In the case of HDFS, together they run parallelly and provide efficient management of data. Then we have streaming of data access with the help of HDFS design. We can read data sequentially from start to end. In large chunks, data reads sequentially. We have to write data once and read many times. And we have high throughput with HDFS. It's suitable for batch processing. We achieve HDFS. Now comes to the features of HDFS. What are the features of HDFS? So first feature is it's suitable for distributed storage, means data distributed in different data nodes. We will discuss it later. What is data nodes? So it is suitable for distributed storage and processing. Second feature is Hadoop provides a command interface to interact with HDFS. Third feature is the built-in servers of name node and data nodes helps user to easily check the status of cluster. So in the HDFS, we have to manage different or collect different data nodes in a cluster, and for each cluster we have data nodes, and to store the information in the data nodes we have name nodes. We will discuss it later. The next feature is streaming access to file system data. We will discuss it later. Then HDFS provides file permission and authentication. So it provides file permission and authentication to the user, that which user is a authentic user to access that particular file. So it provides file permission as well as the access to the user. Now comes to the architecture of HDFS. What is the architecture of HDFS? So in this architecture, we have different parts. We have name nodes, we have secondary name nodes, we have data nodes, and all together they works efficiently for the processing of user requirement. User gives some permissions or some instructions to the name nodes. Name node contains information about data nodes, and the data nodes contains all the information, or we can say this is the physical storage space is called data nodes. So we have name nodes, data nodes, and secondary name nodes. So in the further slides, we will discuss one by one what is data nodes, what is name nodes, and what are secondary name nodes. This is again a architecture of HDFS in which we have a client, client having files of name 1, client having file with name 1, file 2, client have 2 files, file 1 and file 2, and client wants to interact with HDFS. So first the client have to interact with name node. Name node, suppose client wants to write these files, file 1 and file 2. So client requests to name node that I want to write the particular files. But suppose the file size is more than 128 MB. Suppose file size is 128 into 4 MB. So the name node takes this file and manage this file into 4 different files, file number 1, 2, 3, 4, and file 2 is further divided into 3 parts, 7, 8, 9. And the name node map these blocks of file or HDFS file blocks into different nodes. So it randomly assigns these blocks into different nodes, and these blocks stored in different data nodes as per the configuration of name node. Here file number 1 is having a replication in node number 3. Suppose these are having node 1, this is having node number 2, this is node number 3. So data node 1, data node 2, data node 3. So block 1 stores in data node 1, as well as the replica of this data node HDFS block 1 is stored in data node 3. The block 3 also replicated in data node 3. So there can be replication, or some node will be replicated. 9 is here 9, 8 replicated in the data node 2 again. So as per the configuration of name nodes, the blocks will be replicated in data nodes to provide fault tolerance in our HDFS architecture. And we have again checkpoints and backup nodes tightly connected to secondary name nodes. So this is the whole architecture, how a file comes from a client that wants to access or write the file in the HDFS. The file first comes to name node. Name node divide this file into small blocks. Default size is 128 MB, and name node again have some information about the file, and as per the configuration it will gives these blocks to different data nodes, and data nodes will be replicated as per the replication factor. We will discuss later what are the replication factors, and how these name nodes works, how secondary name node works, and what is the functions of data nodes. As we see here, HDFS architecture, it is a master-slave architecture in which master is name node and slave is data node. Master is name node and slave is data node. In a cluster, there must be a single master node, and a cluster can have multiple slave nodes. The file divided into one or more blocks, and each block is stored on different slave machine depending on the replication factor. What is the replication factor? And the factor decides how many replications of the particular file is there. Here the replication factor is 2, but the default replication factor is 3 in the case of HDFS. Master node, or we can say name node, stores and manages the file system namespace, the all information about the file, the size, the type of file, the data node that stores the file. So the master node stores and manages the file system namespace, that is information about block of files like block location, permission, and the slave nodes stores data blocks of file, the data physically stored in data nodes, and the information about the data or the data nodes stored in master node, or we can say name node contains this information or contains metadata, the information about data stored in data nodes. The master node is the name node and data nodes are the slave nodes. Here we have master as name node and slaves are data nodes. This is the physical storage and this is the logical storage, or we can say this contains, the name node contains information about data nodes, the health of the data nodes, the data, the file that contains in particular data node, as well as it contains the free space available in particular data nodes, and all information stores in namespace. We will discuss one by one each and individual part of this architecture, HDFS architecture. First is data nodes, the actual storage workers stores the actual file blocks denoted as BL1, block 1, block 2, etc. And each file is split into blocks, and each block is typically replicated 3 times across different data nodes to provide fault tolerance. If due to any kind of hardware failure, a particular data node is not available, so we can avail that particular data from different data nodes. So this is called fault tolerance. Communicate with name node to report the list of blocks they store. So this slave node or data node communicate with name node to report the list of blocks they store, how many blocks they store, and perform read-write operations requested by the client. What kind of read and write operations requested by the client are performed here, because it contains actual physical storage of data. So all kind of operations like read and write operations will actually perform here in data nodes or slave nodes. Data nodes are inexpensive commodity hardware. Commodity hardware is the hardware that is having low cost, or we can say existing hardware is called commodity or inexpensive hardware. So data nodes are inexpensive commodity hardware. This is the main feature of Hadoop or we can say big data or HDFS, that data is stored in commodity hardware in the form of distributed file system. They store blocks of a file, functions of data nodes. These are the functions of data nodes. Data node is responsible for serving the client a read-write request. So it is responsible for read-write request. Based on the instructions from the name node, data node performs block creation, replication and deletion. So these are the three operations that perform as per the instruction from name node to perform a block creation, to create a block, replication, what is the replication factor, and deletion of a particular node if instructed by name node. Also, data node send a heartbeat to name node to report the health of HDFS. This is the main function of data node, to send heartbeat message to the name node or master node that I am the okay, I am ready, or I am performing well in every 3 seconds to the name node. So name node receives a message from slave node or data node in between every 3 seconds that this data node is okay. If name node or master node doesn't receive the heartbeat message from data node, then automatically it understands that the data node is not performing well, and other operations like user wants to read a data or write a data will be performed from different data nodes that contains that particular file, because the file information is already exist in the name node. So name node instruct the particular user that you have to access this particular data node in place of this, because the master node doesn't receive heartbeat message from data nodes. Also, last function of data nodes, data node also sends block reports to name node to report the list of blocks it contains. The number of blocks it contains is sent to the name node, because here suppose this is a data node, and in data node each block is having of size 128 MB. So if a file stores here, the minimum size is 128 MB, 128 MB. So all this information, suppose this is having a file of size file 1, and this is file 2 and file 3. So how many files contains in particular data node, the information about these files, and the blocks report how many blocks are free in particular data nodes. This is all the information contains in data nodes. Next we have HDFS name node, or we can say a master node. Again, watch this architecture figure. We have discussed data node, what is data node, and functions of data nodes. Now we will cover name node. What are the functions and what is a name node? So HDFS name node used to maintain and manage the file system namespace. File system namespace means the information about the file, hierarchical structure to maintain all the metadata information about the file system or file, because the files are very large in size. So a file can be stored in multiple places to achieve parallel processing. So there must be information stored in master node for each and every file stored in particular cluster in this pattern of master slave. So the name node maintains and manages the file system namespace and provide the write access permission to the client. So client first asks or request to name node that I want to access this particular file either for read operation or for write operation. So the client asks for asks for name node, HDFS name node. Name node, the main concept of name node is name node not stores actual data. Name node does not stores actual data. It stores only metadata, the information about data stored here, not actual data, because actual data stores in data node. It stores only metadata, that which block belongs to which file and where they are stored. There are two types of files that stores this particular information, the file namespace and all kind of information, the health and receiving the health of the data nodes. There are two types of files. First is FS image that contains information. So FS image contains a snapshot of metadata. A read-only file contains snapshots of metadata. FS image stands for file system image, persistent checkpoint file, because it's a read-only file, we can't change it, it's a read-only file. So persistent checkpoint file, and it contains the complete namespace of the Hadoop file system since the name node creation. So all the information contains the complete namespace of the namespace means all the information about the file. So complete namespace of the Hadoop file system since the name node creation. So from the creation of the particular name node, so from the starting of the name node to till date, all the information, read-only information contains here in the form of FS image. These are the information that contains in FS image, file and directory structure of HDFS, file structure and directory structure of particular HDFS of data nodes, ownership and permission, that which user is having which ownership and having which file access permission, file to block mapping, which file will goes to which block, or we can say which file goes to which data node block. This is a work of name node, and the information about this will store in FS image. So the user wants to access the particular block in the further extent of time, so that will ask to name node, and name node contains FS image. In the FS image it contains file to block mapping, that you have to go to this particular data block or data node to access this particular file either for read operation or write operation. And replication labels, this is also stored in FS image, that how many replication factor is for the particular file. Default is 3, it can vary to 4, 5 and any amount of replication label. So replication label, so this is the 4 information that contains in FS image: file and directory structure of HDFS, ownership and permission, file to block mapping and replication labels. This all information contains in FS image. And second file is edit log. First is FS image and second file is edit logs. So first file FS image contains read-only information and the changes that happens in between this operation, like changes in the size of the file, changes in the data in the file, changes in the location access of the particular file, if file is deleted from a particular location in the data nodes. So all this information will be stored in edit logs. The sequence of change since last snapshot or write ahead log, from the first to last, all kinds of logs will be maintained here. Any changes that happened in particular file or in block will be stored here. It contains all the recent changes performed to the file system namespace to the most recent FS image. So till the recent FS image, all the changes information will store here. and together these two files, fsmas and edit log, used to perform or to allow us a fault tolerant and consistent metadata recovery. These features will be achieved if these two files work together, fsmas and edit log. Again, we have third component of our architecture. We discussed data nodes, we discussed name nodes, and now the third part of HDFS architecture is HDFS secondary name node. It's not a backup node as the name secondary name node, so it's a confusion that it's a backup of name node or information of name node will be stored here as a backup. It's not a backup node. There is many other tasks or operations or workings of this secondary name node. The main job is periodically pulls the edit logs and fsmas. It pulls edit logs and fsmas, the two main files, edit logs and fsmas, from the name node or master node, and merges them into a new checkpoint to keep the system efficient, because name node runs 24/7. So it's hard for the name node to update these changes in the edit log in fsmas, because fsmas contains only files and edit log contains the changes. So these changes that happened in particular data nodes about information of the file, location of the file, health of the data nodes, changes time to time, and all this information will be stored in edit logs. And edit log, it's not possible for name node to update fsmas. So for updating this information, edit log information in the fsmas, we have secondary name node. It periodically pulls the edit logs and fsmas from the name node and merges them into a new checkpoint to keep the system efficient. We merges these two files and again provide this updated fsmas file to the name node. So this checkpoint image is having fsmas as well as merge log or stored as backup. It helps to reduce the size of the edit log to prevent the overload to name node restart. So there is no need to restart the name node, automatically back up the information from the secondary name node to the name node via performing this operation, pulling edit logs and fsmas, merging them into a checkpoint and keep the system efficient to run 24/7. Now comes to the functions of name nodes. So these are the functions of name nodes. It executes the file system namespace operations like opening, renaming and closing file and directories. Name node manages and maintains the data nodes. So management of data nodes. Third function is it determines the mapping of blocks of a file to data nodes. Next function of name node is it keeps the locations of each block of a file, where the file is stored, location of file. Next function of name node is name node takes care of the replication factor of all the blocks. So replication factors will be take care in the name node. Next function is name node receives heartbeat and block reports from all data nodes that ensures data node is alive, or we can perform operations from that particular data nodes, because we have to manage commodity hardware in the HDFS architecture. So these commodity hardware that are inexpensive hardware can be fail at any time. So we manage the information about the particular health of data node in name node, and this information will be sent from data node to the name node in between every 3 seconds. And if data node fails, the name node chooses new data nodes for new replication. So if a name node fails, so data node fails, so name node chooses new data nodes as per the configuration that this particular data node will contain the replicas of that particular data nodes, and the replicas will be gathered from different replicas of that particular data node files will be achieved, and this information will be stored in FSMEs. The FSMEs will instruct that this data node that fails contains this files, and these files are stored in this data nodes. So this information will be replicated to the particular data node. This is the architecture of how these name node and secondary name node will function together. Name node contains information like FSMH and edit logs. Secondary node download FSMAs and edits from name node. So this downloads FSMAs and edits from name node will be stored here in the secondary name node, and the secondary name node stores this edit logs and FSMAs and apply edit logs to FSMAs, and this edit logs queries